Okay, as we begin kind of looking at the trig functions in general, when we define them on the unit circle, it's actually pretty easy to define them on the unit circle based on the unit circle's properties. Hopefully you'll look into this more in your classes, but just to go pretty simply here, when you're dealing with, this is only when you're dealing with the unit circle or points on the unit circle, the trig functions are pretty easily defined. On the unit circle, sine of theta is actually just equal to the y coordinate of the point on the terminal side. Cosine is equal to the x coordinate. Tangent is equal to the y coordinate over the x coordinate. Cosecant is equal to 1 over the y coordinate of the point on the terminal side. Secant is equal to 1 over x, and cotangent is equal to x over y. If you've dealt with sine, cosine, and tangent before, and you understand this a little bit, the reason for this is the radius of the unit circle is equal to 1, which helps us define these ratios in this way. Alright, then the unit circle will be helpful for evaluating trig functions for the angle in question, and we'll talk about that. Okay, now to understand this a little bit more, what we have to understand are the properties of the quadrants and their effect on x and y, which is pretty simple. It's something you've probably done since 6th or 7th grade, maybe earlier than that. Looking at the definitions of the 6 trig functions, which are defined by x and y's, the signs of x and y coordinates will have an effect on their value. Okay, notice in the in quadrant 1 here, where theta is going to fall between 0 and pi over 2, okay, x is greater than 0 and y is greater than 0. So all trig functions, okay, will be greater than 0. In quadrant 2, okay, where theta is going to fall between pi over 2 and pi, here x is less than 0, y is still positive, so actually sine of theta is the only one that will be greater than 0. It's the only one that will be positive. Okay? In quadrant 3, x is negative, y is negative, and so actually if you think about this, since tangent is the is y over x, a negative divided by a negative is positive. Tangent will be the only one out of the 3 basic trig functions that will be positive. And when I say basic trig functions, sine, cosine, and tangent, the other ones are considered their reciprocals. Lastly, in quadrant 4, x is positive, y is negative, and so here cosine of theta is the only one that is positive. Now, I'm not a huge fan of this, but as a mnemonic device to remember which ones are positive in what quadrants, there's a famous saying that all students take calculus, and you get that from all students take calculus, okay, for all trig functions, sine, tangent, cosine. So let's use this knowledge now to help us solve a problem here. Okay? Alright. Evaluate the 6 trig functions for 7 pi over 6. Well, conveniently, we just did 7 pi over 6. We figured out that this is 7 pi over 6. Its reference angle was pi over 6, or 30. Okay? And that gave us the coordinates here that were negative square root of 3 over 2, negative 1/2. And we know that the radius is 1. Okay? So using the unit circle is pretty simple. If we know the point on the terminal side, sine in this case is just equal to negative 1/2. Cosine is equal to negative square root of 3 over 2. That's the x-coordinate. Tangent, which is y over x, so it's going to be negative 1/2 over negative square root of 3 over 2. Okay, now we need to take a second and look at this. This is the same as saying 1/2 times 2 over square root of 3, because dividing by a fraction is the same as multiplying by its reciprocal. I changed them both to positive because we have a negative divided by a negative. The 2's will cancel out and I get 1 over the square root of 3, which if I rationalize it is the square root of 3 over 3. Notice tangent's positive in that quadrant, which is consistent with what we found up top. Now each one of these, to find cosecant, is going to be simple. It's the reciprocal of sine. So in this case it will be negative 2, because that's the reciprocal of negative 1/2. Secant is going to be negative 2 over the square root of 3, but if your teacher wants you to rationalize that, which I will have my students do, that's negative 2 square roots of 3 over 3. And cotangent, when we do cotangent, we'll want to look at this spot right here. We don't have to necessarily look at the rationalized part. Let's remember that at one point tangent was 1 over the square root of 3, so that just makes cotangent the square root of 3. Notice if the function like sine is negative, then its reciprocal is negative. Okay, tangent was positive and its reciprocal was positive.